Hey, it's Neil Smith here. Hope you're doing well. The following problem seems a bit overwhelming, but be patient with yourself. It's just adding, subtracting, looking some numbers up in tables, throw in a few nuances, a couple concepts to keep straight, and before you know it, you'll be doing these problems. They're not that bad. You got this. Determination of compass error by azimuth of the sun. Practice problem 8. Let's get this thing going. Problem 8. And we have some givens. And what do they give us? They give us, first, the date. It's January 14th. So they give us the date, which is equal to January 14th. And they give us our zone time, 7:46. Zone time is equal to 7:46. And our DR position, so our DR position is equal to latitude 2637.0 north, latitude 26 degrees 37.0 minutes north. They give us our longitude, which is 153 degrees, 19.0 minutes west. And they give us, at that time, you observe the sun bearing 123. So the sun's bearing 123 degrees PSC. PSC. The chronometer reads 5 hours, 49 minutes, 16 seconds. So the chron time. Chron time is equal to 5 hours, 49 minutes, 5 hours, 49 minutes, 16 seconds. The chron error. They give that chron error to us is 2 minutes, 29 seconds fast. 2 minutes, 29 seconds, and that is fast. And when it's fast, we subtract. The variation is given as 3 west in the problem. Variation is equal to 3 degrees west. And the problem wants to know, what is the deviation of the standard magnetic compass? So it wants to know deviation. That's what we're looking for. What is deviation? We'll start off by getting our approximate GMT, or Greenwich Mean Time. That'll tell us if we're in the right day, and it'll help us take the ambiguity out of the chronometer. So approximate GMT. We start with our zone time, which is equal to 7:46, and take our longitude. Our longitude is 153 degrees, and it's west. Divide it by 15. That'll get us back to Greenwich Mean Time. So 153 divided by 15, 153 divided by 15 equals 10.2. We're going to round that down to 10. So 10.2 rounds down to just 10 hours. We need to know if we're adding or subtracting these, and this west tells us. But let's lay that out in a graph just so we can get an idea what's going on. These are time zones. This is the prime meridian. Greenwich Mean Time runs right through here. And when we go to the east, we are adding. And when we go to the west, we're subtracting time. You can think from New York to California, you go west and you subtract time. So we're in the west. We need to get back to the prime meridian. So we go back. We need to add this. So we're going to add this 10 hours to our zone time. Add 10 hours. 46, 17. So this is our approximate GMT. This is the right ballpark. Now let's go to our cron time and get the actual GMT. So we take our cron time, 5:49:16. Cron time is equal to 5:49, 5 hours, 49 minutes, and 16 seconds. And then we put our cron error in there. The error is fast, so we subtract it. So 2 minutes and 29 seconds we need to subtract. 2 minutes, 29 seconds we subtract. So you can't take 29 from 16 right away. We need to borrow. So this would turn to a 48. And this would turn to 76. So 76 minus 29. 76 minus 29 equals 47. 47 seconds. 48 minus 2 is 46. 46 minutes, and then our 5 hours. So let's look at this, 5:46. This 5 hours does not line up with the 17. So this chronometer it runs on 12 hours like an analog clock, so there's ambiguity in it. We need to know whether we're day or night. So what we can do is simply add 12 hours. We add 12 hours to 5. We get 17 hours, 46 minutes, and 47 seconds. So now we're lined up, 17:46. And this is our GMT, which happened January 14th. Good, here we are. Now with our GMT, we can get the Greenwich hour angle, or GHA. So first we'll get the GHA of the hour, 17 hours. And then we'll get the GHA of the increments, which is 46, 47, 46 minutes, 47 seconds. We'll add these together. And when we get this GHA of 17, our declination is going to be right there too. So we're going to get our declination numbers and our D correction. So now we're set up here. And let's get GHA, 7 hours, 17 hours. All right, we're in the Nautical Almanac. GHA for January 14th first. So it's all the way at the beginning. January 28, 2014 we need. Okay, here we are. January 14th. And you see these 13, 14, 15. So we're in the 14. And now we're 17 hours. So January 14th, 17 hours. Good, 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 good. Just double checking. 72:41.6. 72:41.6. 72:41.6. And now the declination you'll see is right here. So 17. So it's S21, South 21, 13.7. South 21, 13.7. South 21, 13.7. South 21, 13.7. All right, and our D. Let's get our D correction, which down here you'll see its D is 0.4. Okay, 0.4. Now, do we add that or subtract it? That's what we need to figure out. And the way we figure that out is we come to our declination. So January 14th, 17 hours. And here is our declination, S21, 13.7. Now go down to the next hour. Is it adding? Is it getting bigger or smaller? It's getting smaller. So we subtract this. So we're going to subtract this in the end, in the next step. So now these are the increments, 46 and 17, and then we also need to add a correction to this. So we go to our increments table, and we go to 46 minutes. All right, I passed it, 46 minutes. There we are, 46 minutes, 47 seconds. So we cruise all the way down to 47. Okay, and here's the sun column. So 46, 47 seconds, 11, 41.8. 11, 41.8. 11, 41.8. We're going to add those together, but let's get the correction for it. 0.4. So here's the correction, 0.4. We're going to use 0.3. 0.3 negative. We are going to subtract this. 7 minus 3 is 4. 13. So we got south 21 degrees, 13.4 minutes. That's our declination. Now let's get our the GHA of the sun. So GHA sun is equal to the sum of this. Just going to use the calculator. 41.6, 41.6 plus 41.8. 41.8 equals 83.4. 83.4. And then we're going to add these 72, so that's 83. 83 degrees. So, yeah, let's bring this down. So we take 60 out of here. We'll add 1 degree and take 60 out of here. So this would be 23.4, and this would be 84. So that's our GHA of the sun. And now we have a west longitude, right? We're going to try to get the local hour angle now. So the LHA. So we have to account for our longitude, which is west. And when it's west, we subtract. So our minus west longitude. And our longitude is 153 degrees, 19.0. So we need to subtract these. You can do 19 minus 23.4 minus 19. We can do that one. 23.4 minus 19 equals 4.4. 4.4 minutes. We can't take 153 from 84, but really we're just on a compass, so we're going around and around, right? So if you add 360 to 84 and then subtract, you'll get the right number. 360 plus 84 equals minus 153 equals 291. 291 degrees. 4.4, and that's our LHA. That's LHA, or local hour angle of the sun. Okay. Cool. Now we're going to bring it up into a table. We're going to say our declination is one that we need, our DR lat. Need that in the table, and our LHA of the sun. Now, declination, south 21 degrees, 13.4. South 21 degrees, 13.4 minutes. Our DR lat is 26 degrees, 26 degrees, 37.0 minutes north. 37.0 minutes north. And our LHA is 291 degrees, 4.4. 4.4 minutes. Good. What do we get from here? We know that our DR lat and our deck have contrary. They have opposite signs or names, you can say. So our deck and DR lat are contrary. So now let's get our base argument. Our base argument is 21 degrees, 26 degrees, and 291. Okay, this will let us get our base Z, or base angle, out of the site reduction tables. So here we are in the site reduction tables. And we need LHA 291. LHA 291. So we're contrary 291, 26, 21. So here we are. There's the same side and the contrary side. We're on contrary 291 and 26. Here's the Z column, and we need a 21 deck. 21. There we are. So we're contrary 291, 26, Z column down, 118.3. 118.3. This is our base, and it goes for all of them. Now we can get our tabulated Z. What is that? Tabulated Z, we just bump each argument up by 1 and then recrunch the numbers. So this declination becomes 22, 26, 291, and we'll record it here. And then this becomes 21, 27, 291, record it here. And then this becomes 21, 26, 292, record it here. And that's our tabulated Z. So let's do that. So first we'll bump the declination up by 1, so it's 22. Underline the 22. And now we're contrary 291, 26, Z column down to 22, 119.1. 119.1. And now we'll bump, so we'll go 21, 26. So we're going to be at 21. So contrary 291, 27, Z column down to 21, 118.4. 118.4. Now we'll bump our LHA up 292. Yeah. So here we are. Contrary 292, declination 21, DR lat 26. Z column down 118.8. 118.8. And now we can get the difference between the tab and the base Z. So we get the difference in Z. Let's just put them all in the calculator. 119.1, 119.1 minus 118.3. 118.3 equals 0.8. 0.8. This one I can tell. Let's just put it in. 118.4. 118.4 minus 118.3 equals 0.1. 118.8, 118.8 minus 118.3, 118.3 equals 0.5. They're all positive. You can see these numbers are all bigger than the base numbers. So our next row are the increments. The increments are just the minutes. So 13.4 and 37.0 and 4.4. With this, we can get the correction. So the correction is equal to the difference times the increments divided by 60. The diff times the increments divided by 60. Let's crunch those numbers. 0.8 times 13.4 equals divided by 60 equals 0.18. 0.18. Let's do the next one. 0.1 times 37 equals divided by 60 equals 0.06. 0.06. And 0.5 times 4.4 equals divided by 60 equals 0.04. Okay, and this will give us the total correction. What's the total correction? 0.18 plus 0.06 plus 0.04 equals 0.28. We're going to round that. 0.28. Well, it rounds up to 0.3 is what we're going to use for the correction. So if we come over here and get our base z, we're going to apply the correction to our base z, which equals 118.3, 118.3, and the correction is positive. We're going to add it to 0.3. This is going to give us our z value, and it's going to be in quadrantal notation. So we add it. So it's 0.6. So 118.6. And now we need to label it. We need to name it north or south right here. And it gets named the same as the DR lat, north. And now we need to figure out whether it's east or west. So we do that with our LHA is greater than 180, so it equals east. If it's less than 180, it would equal west. In this case, it's greater than 180, it equals east. And so our Zn is from north. So let's map that out and take a look. If we draw this little compass here, we get north, south, east, west. And so we're from north, so we're working with north, and we're east of north, 118.6. So there's 90. It's going to be somewhere down in here. So this is going to be our z. But if you look at it, this is also Zn. This is our angle from north. So in this case, z equals Zn. So Zn is going to be 118.6 degrees. Now we can correct our compass. We can say T, V, M, D, C, true variation, magnetic deviation, compass. If we're going down, we add west. So true is 118.6, 118.6. And our variation was given. What's our variation? 3 west, 3.0 degrees west. So we add that. 118.6 0.6. 118.6 plus 3 equals 121.6. 121.6. And now we were given our compass over here, sun bearing 1, 2, 3. 1, 2, 3 degrees PSC. So 1121.6 minus 123 equals, so 1.4. We need to know, is that east or west? 121 to 123, we need to add. So it's west. So with all of that, we got 1.4 degrees west. Let's look at our answers. There it is, right up top. A, 1.4 west. So the answer to determination of compass error by azimuth of the sun, practice problem 8, is 1.4 degrees west deviation.